Hello, everyone, and welcome to the Switch Statement Podcast. It's a podcast for investigations into miscellaneous tech topics.
This is episode 3 in our series on the design of everyday things by Don Norman.
Hey, John, how are you doing?
Hey, Matt. I'm doing pretty good. How are you?
I'm doing all right. I don't know. Don't have anything too much to complain about.
Yeah, me neither. I recently had COVID for the second time, which was better than the first time, but still a negative experience, I would say.
New features. COVID 2 has fewer bugs.
Yeah, had fewer bugs, lower fever, much lower fever, because I had a very high fever the first time around.
Nice. I didn't check the release notes. That's good to know.
Yeah, that was in there somewhere.
I'm going to upgrade.
Yeah, look forward to it.
But yeah, so today we're supposed to be talking about error. Is that, am I correct about that?
Yes, human error, which was kind of a secondary theme, or one of the two themes in chapter 2 of Design of Everyday Things.
Right. So this is, just to recap, this is the psychology. Psychology? Is that the right word?
I believe so.
Right?
Poet?
Man, that just sounded really weird. All right. The psychology of everyday actions. This is, that's what the second chapter is called. And then the last one, we went over just this like framework for thinking about actions that you're performing. And now today we're going over like what happens when it goes wrong.
Yes.
And he has a lot of interesting thoughts here about blame. It's almost like therapeutic. It's like, you as the user, when something goes wrong, like you don't blame yourself. You need to blame the designer.
Yes. Or the engineer. I both loved and hated this chapter. Loved because he's absolutely right. Usually if mistakes are made with a piece of software or like an everyday object, it's the issue lies with the designer of that thing. But he was very hard on engineers. Like there was one point where he straight up said the laziness of the programming team is the source of some particular problem. And the sections really stressed me out because he was talking about like date formats, which is actually, people who are unfamiliar with software may not know this, but dates are one of the hardest things to work with in software because there's trillions of formats, there's trillions of time zones, there's all sorts of edge cases. There's great libraries out there, but there's also terrible libraries out there. Like Java's, inbuilt library, or built-in, I don't know why I reversed those words, but Java's built-in date library was famously just jank AF, for a million years. And now we have things like JotaTime, which are much better. But, back in the day, it was very hard to get dates right. And he had this whole section where he was talking about supporting like millions of different date formats in order to make life easier for the user. And I was like, dude, do you know how much engineering resources it takes to like fully support all these crazy date formats?
Well, this is one thing that's super interesting is he says Microsoft's calendar accepts dates like November 23rd, 2015 with 23 Nov 15, 11.23.15. And the last example is interesting because that's one where it's possible for there to be ambiguity.
Right.
And so it's the kind of thing where when you make it more flexible, you also open up the possibility that if you're trying to make it magic, that you misinterpret what the user says. And so I think he was like a little bit dismissive of those trade-offs because it's like in that case, like you can still resolve that. Like let's say you say 01/01/15. Or well, I guess that's not ambiguous, but it's like 01/02/15, right? Mm-hmm. Like
is it January 2nd or February 1st?
Right, exactly. Now you need to pop up a dialogue that's like, hey, just a heads up, like, is this one or this other thing? Or you need to have like a default, like you have to guess from their locale what they're saying. But then all of those have these like trillion little edge cases.
Right.
And
it's interesting because there's a directly competing engineering maxim, which is like, the simplicity of your software will pay dividends to the user. And
right.
By the way, I'm saying this like it's some well-known thing. I think I just made that up on the spot. But conceptually, it's a well-known thing where if you design your software super simply, and the fundamentals of your system are simple and ultra easy to understand, you may be asking a little bit more of your user, but at the end of the day, it's actually going to pay dividends to your user because it enables your system to be simpler. Engineers can work with it more easily. Engineers can add features more easily. Simpler components generally compose better in order to form more complicated components that actually work. So there's this interesting, engineering thing where we do sometimes try to keep things simple at a small cost to the user experience, because we know that like keeping things simple will actually, at the end of the day, benefit the user. And it's a little weird, and it's hard for, I think, someone like, what's this guy's name? Don Norman. It's difficult for an outsider to sort of internalize that, because they just see software as like, this thing that, you can just add a feature. Like just support this additional thing. And it's like, that's not really how software works. Like every little thing has to interplay with every other little thing. So every tiny feature you add, kind of creates this permutation that, it's a new permutation. So
this is interesting because there's a couple of different avenues where I could go down, and like Apple comes to mind again in a couple of different ways. In one way, I think Apple does this well because they sometimes restrict configurability, and I think the point is that when there are fewer configurations for there to possibly be in a system, those configurations are just going to work better because there's just like fewer permutations. But then, I don't really like that. I like to have full control over things.
Yeah.
So I prefer a system where things are pluggable. But then you get into a situation where, with like Linux, where does any of these two combinations of modules like work together? It's really hard to know. So,
which is why API design is so incredibly important, because at the end of the day, this is what, designing something to be composable, to be simple to use, but also composable is actually an extremely hard problem. And something that if software engineers, the more we get it right, the better it is for everyone, but we get it wrong all the time. But
then, so one last, I definitely agree with that, and I don't want to walk past that. But the one counterexample with that, there's this thing where in Mac OS, when you're sorting directory names or sorting files at all, they seem to ignore leading zeros. Which it's a very interesting decision because it feels like you're catering to a very specific situation where you have one folder named 1 and one folder named 02, and you want the folder named 02 to come after the folder named 1. Mm-hmm. But what this winds up with is like, on my system, there's these series of directories which have UUIDs, and it's like, I just want to sort these UUIDs, and it's like, they're not sorted. They are just fundamentally not sorted because they're ignoring leading zeros.
Right.
So it's the kind of thing where it's saying like, oh, well, users are going to think about these numbers disregarding a leading zero. But then you need to throw away like true string sorting in these other contexts, which just seem like an absolutely batshit insane thing to throw away for like this one edge case that might like work well for users in this other situation.
Yes.
And so I think that's kind of a hard decision where you're like, okay, are users ever going to have directories that have important leading zeros? Or should we make it easier for people to be able to sort arbitrary numbers? Because presumably this would allow you to sort like 1 through, or I don't know how it works. Because they're definitely not numbers, so it's not as if they're trying to do like a 2int on this string, and then if it becomes a number, you sort it as a number.
Yeah.
They just seem to be dropping leading zeros. So anyway,
that is strange.
That was far too long of a ramble about that. But I think these are 2 different examples.
Yeah, no, it's a good point, because it's like there are situations in real life which just are ambiguous. You know, like we don't use Lojban, we use English, which is a language that contains tons of. We should use Lojban, yeah. But yeah, so this is another part of what makes software design so hard is you're trying to represent situations which actually contain ambiguity just intrinsically. So it's just tough.
To get back to like how this dovetails with the book is he talks about how engineers are very rigid and they have this very like rules it's true, perfectly logical, and the problem is with the user. And I'll be honest, those are thoughts that I've had before. I was like, this system, it works logically, like why can't the users use it? And I think it is really important to understand like and I like just how that ties back is like I feel like, oh, it's logical to just sort them as strings, but like at the end of the day, the vast majority of end users might just be like, just sort these as numbers. And so maybe it is like actually the right design decision according to Don Norman, and I'm just being that overly logical engineer.
Yeah. Did we talk about, so there was a section, and I love this section, where he talked about cognition provides understanding and emotion assigns value. Did we discuss that? You
referenced it, but we didn't really discuss it in depth.
Okay, cool, because I wanted to talk about this. I guess this isn't super related to blame, although I think this can create situations which, can result in bad decisions. But this is something that I think about a lot in my career, because as an engineer, at least when I was younger, like basically just starting out as an engineer, I came to realize that my emotions were almost always wrong. Like I would be presented with a problem and I would have this quick kind of snap judgment, like, oh, let's just try, this or whatever. And it just would straight up not work because I was missing some nuance of the problem. And I think it's because a lot of problems in engineering, like, first of all, computers do exactly what you tell them to do. So it's just very hard to know exactly what you need to tell a computer to do in order to solve like a real world problem. But also problems are usually just much more nuanced than you realize, because in your day-to-day life, well, I don't know what the reason is, but I guess just as a software engineer, a lot of times you're dealing with these problems where you need to get like 8 trillion details right in order for it to actually work. But anyway, as I've gone through my career, I have noticed that, and I think this is just an experience thing, but as I am presented with problems today, and this isn't true for every problem, this isn't like a humble brag or anything, but like my emotions have more value to me. And it's been interesting because I feel like I've spent most of my career rejecting my emotions, kind of like trying to keep them at bay as much as possible. But in the past maybe few years, I've come to realize that like, oh, those actually do have value. And like sometimes an emotion that I immediately feel about a problem is actually based on this like intuition that I've been developing, kind of unbeknownst to myself. And, but it's also tough because in an engineering context, it's almost impossible to tell people like, oh, I just know that solution A is going to work. People just won't believe you. That's the type of thing that just gets immediately rejected in an engineering context. So, yeah, and I don't know. I didn't really have a goal in.
Could you repeat the original quote again?
Cognition provides understanding. Emotion assigns value. So I think my read of this is like, you're learning about a problem in engineering. The emotion that's assigning a value to that problem is wrong. Like when you're just starting out as an engineer, your emotions are just giving you incorrect answers. So you need to rely almost entirely on this like cognition, and you need to spend more time and deeply understand the problem. But as you venture further in your career, your emotions will start to have value at a certain point because you've seen all these situations and you sort of understand the shape of problems.
It's interesting because I think I might have a semantic disagreement with the way you're describing some of these things, because I feel like I don't think an emotion can be wrong. So I think there's an intuition about the way a system should work. And then there's the gap between your intuition about the way the system works and how it actually works. And then there's frustration. Like the emotion there is like frustration that you're doing thing A and like thing B is, the outcome is not what you expected it to be.
Yeah. I'm thinking of more like you're presented with a problem, and you sort of go through this exercise of like rattling off potential solutions. And your emotions are telling you like, oh, this solution might be good. Because you can't you can't fully know how a solution is going to work against a problem until you've like done a little bit of research. So in this kind of day zero period where you've generated this list of solutions, your emotions about those solutions can be very untrustworthy, I guess. This is sort of how I'm interpreting this statement, and I don't know, maybe you just have a completely different interpretation of it.
I don't think we disagree fundamentally. I think it is a question of terms where it's like I would almost use the word hunch. It's kind of like you are surveying the landscape, and what I think is maybe you have option A and option B, and you're really excited by option B because it uses a new technology.
Yeah.
That is a place where I think your emotion, like, okay, maybe let me know if this lands with you. It's like you can't decide, or like deciding what to do based on your emotion about an option is the wrong thing to do early on in your career. Because just because you're excited about a potential avenue of approach, that may not, or indeed is likely to be wrong. So you have to defer, instead of listening to your emotions, you have to defer to these more rational, like, evaluations.
Yes.
And be more systematic. Where it's like now, if you're excited about a possible option, there's a much higher likelihood that is going to line up with what the right decision is anyway.
Yes. Yeah, and obviously that analysis is still super valuable, and you should still perform that analysis no matter what your, hunches are. But it's an interesting, it's been an interesting learning experience where I started to realize that my hunches were becoming more and more, they matched more and more with the actual solution that I needed. And I feel like an idiot all of a sudden because I feel like I'm just describing like experience. And, obviously as you gain experience, you are, learning the shape of common problems. But it's just interesting in this engineering context because I feel like I expended so much effort like rejecting my hunches and emotional responses to things. And I'm almost having to like expend effort to like accept my emotions. And it's an interesting thing that I don't know. It probably exists in other careers. I'm sure it does. But it's just an interesting, realization, I guess.
Your point about like comparing engineering to other careers, I think like if you're an artist, and obviously that's a very extreme difference, like trusting your gut, even as a young artist is probably the right thing to do.
Yeah.
I think engineering is meaningfully different in that even if your hunch starts to be more correct, to your point, it's like you still need to do the due diligence to to go through, like, to prove it out, essentially.
Yes. Engineering also has the characteristic where there is a definite right and wrong answer, but there is also a spectrum of right answers where one right answer will actually turn out to be the wrong answer 3 years from now. Yeah. And another right answer will turn out to be really the right answer 3 years from now. And I really think that that's something that's just so hard. I mean, I know seasoned engineers, including myself, that still constantly make mistakes in that realm. And the only advantage we have is that we're more aware of that type of thing. And
you've just seen how those decisions break, essentially.
Exactly. Something seemingly so innocuous, the name of something, or, just a function signature or something, like something to seemingly tiny detail. And it just kind of turns out really biting you later on in life.
Yeah. There's something I wanted to bring up so he talks about falsely blaming yourself. There's a section that he says called falsely blaming yourself. Yes. And he says where he studied users and they do something wrong and they're like, oh, like, I'm so stupid. Like, I did it wrong. And he comes out pretty strong on the problem is the design. Mm-hmm. And it's funny because as a designer, I think it's really important. Like, you are like the thing that you can control is the design, right? So it's like when the user does something wrong, the thing you can't control the user. Like, you can tell them things, yeah, of course, but like the core thing that you can control is the design of the thing. And so he's kind of taking this very strong stance. When the user does something wrong, the problem is the design. And I think that's really useful. But it's funny because when you are a user and you're trying to use a product, you can't fucking blame the design. It's like there's nothing like, it's like, oh, like, stupid thing, like, and then it's like it still doesn't work, right? Yeah. So it is funny to me because he doesn't call out the fact that when people are using things out in the field, when something goes wrong, literally the only thing they can blame is themselves, because it's not like they have any control over the design at that point in time.
There's no value to blaming the designer because you're still stuck with a thing you can't figure out how to use.
It's not reasonable for them or it serves no functional purpose for the user to blame the design at that point in time. It's just like crossing your arms like a little kid and being like, stupid things, doesn't work. Like, it's like, of course they're going to blame themselves because, sometimes the thing literally just doesn't work, like, is doing the wrong thing. But a lot of other times, engineers, the engineers designed it in a quote unquote logical way. So there is a way that it's supposed to work, but the user is kind of correctly assessing that they just don't know what that correct way to do it is.
Man, I was getting Bill O'Reilly with the teleprompter vibes when you were talking about just complaining about something not working.
Oh yeah.
But yeah, no. Yeah. I feel like there's a point where he's like, stupid thing sucks. And it just reminded me of acting like a baby. But no, that is such a good point. And I think it's interesting to talk about blame because, in our careers, for instance, blame is a very well-known thing. In fact, there's even like a thing called a blame layer in code where you can see the author of code, so if there's a bug on line 66, you can literally see that, I wrote that line. And And so I feel like the way that our culture sort of views blame or like interacts with blame has been this like it's just this very polarizing thing where, you know, some people are all about like, oh, a problem happens, like let's figure out whose fault it is. But then other people are like, let's be entirely blameless and just solve the problem, and then, you know, put in place like safeguards against that problem ever taking place again. And I feel like I have developed, you know, maybe an interesting take on blame, which is to actually like actively try to find a way to blame myself. You know, like if some problem happens, find what, even if you are so like not related to the problem, like you're so far away from the problem, still try to find a way to blame yourself, because you might be able to find some flaw in like the overarching process which led to this issue taking place. And yeah, I don't know. I just think I think blame just automatically gets this like negative connotation, but I also think it can be a valuable exercise because you can find like systemic issues. I guess this is completely different from what you were just talking about, but it's kind of another interesting topic about blame.
It's still interesting. I do think blame, and yeah, maybe this is just my assessment, I do think blame intrinsically has a negative connotation. I think it connotes like, I think the most salient interpretation of blame is one person blaming another person. You know, I think you can kind of blame yourself, but I think that's kind of a secondary interpretation, or like a secondary usage of it.
Right. Yeah, I guess it's I mean, the word, well, now I kind of want to like look up the definition of the word blame, but does the word blame imply that the person being blamed was kind of like screwed up, or like, yeah, I guess I don't even know. Or does it just imply that they performed the action which led to a bad event? Because those are kind of two different things.
Those are two different things, and I think blame does yeah, okay. So assign responsibility for a fault or wrong. And it's funny because that feels very like, that feels kind of, what's the word? I'm like sanitized, I guess.
Yeah. Right. Like that's still, I feel like that still has the ambiguity where is it implying that what you did was wrong? You know, like you straight up murdered someone, like that's just wrong. Yeah, I'm blaming you for the murder of this person. Or is it implying that you performed some action, which might, on the face of the action in isolation, it might have been completely, you know, whatever, innocuous, but then ultimately some bad thing happened.
And this is interesting, and I almost feel like blame requires some ambiguity, because and I was thinking about this when I was reading this chapter in the morning. It's like the problem here is the interface, and I feel like a lot of times people use interface just to describe like how a thing looks or how you use something, but I actually want to use it in the term like, this is where two things are meeting. You know, the interface is like, okay, this is where thing A meets thing B, and thing A is a human and thing B is the designed product, right?
Yeah.
So and like them meeting is the interface, right? It's like there's two parts of this. So something went wrong, and the reason why blame comes into the question is, was it the fault of thing A or was it the fault of thing B? It's kind of like a problem at their interface. You know, there's not a problem doesn't exist devoid of both things together. You know what I mean?
Right.
So like it's unclear who was at fault essentially, and that's where it's like, okay, well, the user is blaming the item, and then I don't know, the item can't really blame anything, but maybe the item's designer is blaming the user.
Yeah, and I guess this is part of the reason I think I've developed this philosophy, because if you use that framework and both entities, you know, both the object and the user find a way to blame themselves and also find a way to kind of improve that interface, then, well, maybe they'll both change to a point where they still can't understand each other. But I guess I see a world where it's kind of like both things are improving. Both things are finding the flaw. Maybe the user like just doesn't use technology a lot, and so they don't know like certain paradigms, which are actually very common. This actually happens to me all the time, where I'm trying to use some new app or something, and I'm like an old man, like I just don't understand some new like digital paradigm. Or it could be an issue with the design of the app, where it's like maybe something is just not obvious. But if both of those things improve, then the world improves. So
right. I think the way that I view it is I try to dispassionately assess what happened, understand what I did in that situation, understand how that mapped onto what actually happened.
Yeah.
And then try not like, or just think about okay, if I'm in the same situation again, how should I behave going forwards?
Right.
And crucially, I feel like blame does involve, and maybe it doesn't. Maybe this is something that I'm imbuing the word blame with. It associates shame with it. Like you should feel shame that you caused this, issue. And I don't think that that's useful. I don't think anyone benefits from. It's like, oh, you should be ashamed of yourself. Like I don't think that that's right, and I don't think that's what you're saying. To be clear, But yeah, so that's kind of how I reason about it.
No, I think you've did a great job of describing kind of how a blameless culture should function, which, to be super clear, I am totally a fan of the blameless culture. Like, I completely agree. Blaming someone and kind of calling someone out for like something they did wrong just has zero value, and if anything, has negative value. Because you're both creating an asshole of yourself and you're also making that person feel bad. So big fan of blameless culture, but you need to be able to learn from some bad event. So the way that you just described of sort of assessing the situation, putting in place the guardrails that prevent it from happening again, like that's the most important thing at the end of the day. When a mistake gets made, is just kind of ensuring that we avoid it in the future.
Yeah. I mean, there's a ton more that I think we could talk about. I mean, was there anything else you wanted to bring up?
Yeah, I don't think so. I'm just going through my notes. Unfortunately, I didn't organize them by like blame theme, but I do think those were kind of the main things that I had for blame and human error. Yeah,
I mean, the only other thing, and we can make it brief because I know we're running long, but was just around errors and how, like, I think it's so crucial that you understand. Like, it's really easy to write the happy path, and you're like, okay, this is what should happen in the positive case.
Yeah.
But there's always a trillion and one things that can go wrong, and indeed, it's. I feel like I've heard some statistic which is to the effect of 90% of code or 80% of code is handling these exceptional cases. And I think if there's one major takeaway from this chapter of the book, it's like incredibly important to, like, things go wrong. And actually, people are they're actually very accepting when things go wrong. What they hate is not knowing what is happening. And so, like, obviously if things are going wrong a lot, they'll hate that too. But the thing that stresses people out is like, did this thing save? Is my document up to date or what have you? And so giving people the tools to know if the action they performed worked is so crucial.
Yes, absolutely.
All right, but let's leave it there. And so let me just look up really quick.
So chapter 3 coming up.
Chapter 3. Oh, wow. Okay, this one has a pretty wild title. I have no idea what it's about. It's called Knowledge in the Head and in the World.
What?
So I feel like there's a lot of different directions this guy... Like, that sentence I didn't even really understand what it was saying until I said it out loud. And even now,
yeah, I still don't understand what it means.
Don't know what that's supposed to mean. But we'll find out next time.
It's a teaser.
All right. Well, I'll see you next time, John.
See you later, Matt.